11. Just figure I better have these in my hands. I want you to brace yourself. No, markers are not in our hands right now. They are laying on our board, pushed to the corner, out of our way. Okay, just don't let those things become a distraction. It pains me to say this, but today we are moving on from rounding.
No.
I know that this may be empty in a little bit because there will be such great sorrow. Now, we are not leaving rounding forever. Our old friend will be around and will pop up when we least expect it. We'll practice it for sure here and there. In fact, we may get a little practice today. But we are officially not having a rounding lesson. So, you gonna make it? You gonna be okay? Okay, just making sure. Because I know there's been such excitement in the room about rounding the last few days. You guys really have gotten good at it, by the way. And I have watched you.
Of course, when we get good at it.
Yeah, right when we get good, we're gonna switch it. It is time to move on. Now, the thing is, guys, anything we learn or go over, we don't want to lose. You know, we've worked way too hard to get good at that to lose it. And so we want to every now and then keep practicing it so we don't forget how to do it. But today we're moving on to lesson 11. I can use place value understanding. You see, place value is kind of helping us with a lot of things. Okay? To fluently, let's stop right there. I want to know what that means. You hear that word in reading, you hear that word in here. What does it mean in reading? If you can fluently read, what does that mean? Yes. Smooth. Okay. What else might it mean?
You don't sound like a robot.
You don't sound like a robot. Yeah.
You read fluently, like you read it softly and read it.
You just kind of, well, your hand did this every time. It's like smooth. It's like you just kind of keep going along. What do you want to add to that?
I would like to add on to what Will and Reagan said, because when you read fluently, you're reading soft and smooth. And
Okay. Are you having to stop a lot of times when you read?
Because the period.
Okay, now I don't mean for punctuation. We are supposed to stop for punctuation, but do we read it in like choppy little pieces? No. It flows together, doesn't it? And sounds like it's supposed to sound. Okay, so fluency in math. What would that, Bailey, what are you thinking? Okay, keep thinking. Yeah, help her out.
So, how we do splits, like you could just know it like that.
You do. It's where things become kind of automatic. Before this year, it was more addition facts and subtraction facts for you that your teachers wanted you to be pretty fluent in. You might have practiced them in a lot of different ways. Anything from a worksheet to flashcards to a game on the computer or an app on a tablet. All to get you, quicker and smoother with those facts. Now, last year, I think I'm saying this right. Last year was our first year with multiplication?
Yeah.
That's what I thought. Okay. So you get those math facts, those multiplication facts, and you are learning them. That's one thing to learn them for the first time, learn how multiplication works. But then after that, you want to pick up your speed and get to know them easily so that they're pretty automatic. Those math facts, whether it's addition, subtraction, multiplication, they're going to help you the rest of your life. They might help you when you have to go to the bank and work with numbers with money. They might help you when you buy something at a store and you need to know how much change should I get back. So it's good to be fluent in these math facts because they're all around us in the real world. They're all around us at school, obviously, because we make y'all work on them all the time. So we're going to we want to be able to fluently add multi-digit whole numbers. When it says whole numbers, it's just talking about our regular numbers that you've worked with for years now. There's a lot of words today, using the standard addition algorithm. Woo! When you go home tonight, you can be fancy. Yes, at school today, I did the standard algorithm. So you could sound really fancy when you go home. We're going to get real familiar with that word standard algorithm because of what it is. There's a standard algorithm for addition, for multiplication, for division. A lot of times it's the way that maybe your parents or grandparents learn, your aunts, uncles, the ones that are older than you, it's the way they learned it. It's kind of that normal old way that has been around forever because it works, okay? And apply the algorithm to solve word problems using tape diagrams. So we're going to jump in today. In all of that, could you tell what we're doing today? What are we doing today? Who can put it in simpler words?
Multiplication.
No.
Adding.
What do you think?
Adding.
Adding what though? 2 plus 3. No. What?
Adding
Multi-digit numbers. And so we're going to look at some big addition. We're going to make sure we remember how to do it. We're going to make sure we remember how to carry and things like that. We won't spend a long time in addition. After addition, we'll step into subtraction. Get back used to that again with bigger numbers. Because shortly this module is going to end and we're going to be in our multiplication and division module. Okay? All right, let's do some practice. You have your board out. Okay? You have a number, and right here, yeah, just about the time I told you it was going away, here it is. But I did say we were going to practice, so to be fair, I did say that. This is what you're rounding to. You choose the way you want to do it. Just because this is here does not mean you have to do it this way. Okay?
Our buddy has came back.
Yeah, there you go. Oh, happy day. Okay. So we're going to round this to the nearest 1,000. Let me give you a second to do that. Rounding to the nearest 1,000. Okay. If you use the number line, that would have been your 3 numbers. Okay? Then you would have put this number on the number line, which would have been way up here. So it is closer to that. Okay. If you did it the other way, here's the thousands place. Draw that arrow next door. That 9 is like a street sign, a road sign telling the 3 what to do. It's going to definitely tell the 3 to go up to a 4. And all of these become zeros. So we did, get the same answer, just in a different way. Okay, great. I think I see a couple more, so let's clear our board off. And this time, okay, before we get into the rounding, let's read this number together. 74,621. Remember, you're reading it in chunks. Read what that number is. Say 1,000. Read what that number is. Okay, go ahead and round this to the nearest, what?
10,000.
10,000. Pay attention to those details. Good. if you're rounding to the 10,000s place, then you're going to have 10,000 between this bottom number and this top number. Okay? Because you're trying to figure out which 10,000 is closest to. Remember, we only had 7 10,000s. These 4 are not big enough to be a group of 10,000 yet. So we don't include all of that. The only time we put all of those numbers together is when we're rounding to the what place? The thousands place. Because all of these are thousands, but not all of these are 10,000s. Not all of them are 100,000. Some of them are not big enough yet to be that. So 74,621 would come about right there. So it is closer to what?
70,000.
70,000. If you did it this way, is that 4 going to push that 7 to an 8?
No,
It's not big enough. So we're going to keep the 7, and all of these from the arrow over become zeros. Okay. Questions about that? I think a lot of you had that. Okay, we're going to, one more. This time, what place are we rounding to?
100,000.
We are rounding to the 100,000s place. Okay, go ahead and do that one. If I was using the number line, and several of you are doing that, where would my dot go for this number? In the bottom half or the top half?
Top half.
Okay, it's definitely above the middle line. Definitely closer to 700,000. If I did it the other way, that 8 is big enough to do what to the 6? Turn it, yes, go up and turn it into a 7. And then from the arrow over, we have 0. So always count these digits. If you've got a lot of them, make sure you have the right number of zeros. That can change your answer. Okay? All right. So go ahead and clear off your board. And we will keep moving. All right. We have not done one of these in a while, so I want to stop and look at it. Okay? Can somebody read that for us nice and loud? Bailey, go ahead.
Meredith keeps track of calories in
Consumed, which just means to eat.
consumed for 3 weeks.
Okay.
First week, she
Consumed.
12,490 calories.
Uh-huh.
The second week, 14,295 calories, and the third week, 11,116 calories. About how many calories did Meredith consume altogether?
Okay, good job reading those numbers, by the way. All right, so when we have a word problem, what's the first thing let's hold up for just a second. What's the first thing I want you to go in and find and underline? Yeah.
The word that in your question.
Okay. Yes, the question. I think I got rid of my pen. Okay, so our question is right here at the end this time. There's the question mark. About how many calories did Meredith consume all together? Okay. There's two things about that question, so please stop working. Okay. First of all, what does it sound like we're going to be doing with all three of those numbers? What does it sound like we're going to be doing with all three of those numbers? If you had to guess, what would you say?
Adding together.
Adding them together. But there's a word in that last question that I don't know if you caught, but it really asks you to do something else. What? Okay. Yeah.
About how many calories?
About. Are they asking for the exact number?
No.
They're not. Okay. So, what are we going to do?
Add them all up.
Okay. There are times when we will add up the numbers they give us and then round. We saw a problem yesterday or 2 days ago where we rounded first and then we added the rounded numbers. Okay. Today we're going to add them all up and round our final answer because we're going to see how much, the real number is, but we're going to round that. Now, does it tell us a place to round to? No. What do we do if it doesn't tell us specifically round to this place? What do we do? Yeah.
Round to the end number on the where it starts.
Not where it starts, but go to the other side. You're going to round to the largest place value place there is. All of these numbers go to what place?
10,000.
All of these numbers go to the 10,000s place. So we're going to round them to the 10,000s place. Okay? So let me give you a minute to do two different things. One, add up all the numbers. Is that 3 numbers? Yeah. There's 2 ways to do that. You can put them all 3 stacked on top of each other. Or you could do what?
You could take the 2 lowest numbers and combine them and then add those.
Or you can add 2 numbers together first and then add the third one. Either way you want to do that. You're going to add these 3 numbers and then you're going to round your final answer to the 10,000 place. So I'm going to give you a minute to do those 2 things. Okay? You have 2 different steps. Adding all your numbers, rounding that final number to the 10,000th place. Okay. finished, I do want you to keep going. We're going to go ahead and start working it out up here as well. How many of you got 37,901 when you added those three numbers together? That's what you should have gotten. Okay. Please don't just be copying that down. You need to be working this out for yourself. That's how we learn it. Okay, once you got the 37,901, we rounded up. You might have used the number line, which is fine. I just did it the other way this time, and it rounds up to 40,000 calories. Okay, so that would answer the question about how many calories. Because, you know, calories are one of those things, it's hard to always have the exact number of everything you ate. And so, what did she eat those 3 weeks? Well, she ate about 40,000 calories. Okay. All right, any questions about that? I was impressed. We are fixing to start talking about multi-digit addition, and they kind of threw this at you with 3 numbers. But I was impressed how your problems were written. Okay, that's one of the things we've got to talk about. How do you think, or why do you think it's important to write them a certain way? Go ahead.
The reason why that it should write them from biggest to smallest is for you to see your first number and your second.
Okay. It can make a difference sometimes. That one, you could have mixed them up. It wouldn't have been too bad. All right, but what else am I talking about as far as how to write them? Let me give you an example of what I mean. I don't need that. Let's clear that off. What if I had gotten to work on this problem and I had gone like this? Because trust me, I see this a whole lot. So what do you see as a problem here? What is fixing to be a big problem for me, Charlotte?
Your comma is way too big.
Okay, well the comma might accidentally be mistaken for a number. What else though? What's really wrong here?
Your numbers are lined up.
They are not lined up. I have seen this happen so many times. And we wind up adding the wrong thing to the wrong thing. Guys, we know place value at this point. If I'm adding, if I added, oh goodness, it is a mess, isn't it? This one is in the 10,000s place, and this 2 is in the thousands place. You see how they're, not only are they just a mess, you're adding different place values together, which is, the values are so different when you start doing that. Your answer would be so wrong. All right, so we've got to be careful that we are neat when we line up our numbers. Let's go back.
I think you can read that.
Yeah, and I made it extra messy on purpose, but now our old friend place value charts coming back on the scene. Okay, he is a tool that we will pull out a lot. They did not label this, but this is what it would be. What comes next?
10.
And then?
100.
And then?
10,000. 1,000.
Thousands. Let's do that first. and then
10,000.
10,000s. Now I have two numbers, so do I just pick one? Do I pick the most important number to go on there? How do we do this with a place value chart? If you would right now, put the top on your marker, board, eraser, marker, push it to the corner. Okay? Let's take our hands off of all that right now. What we can use our place value chart for is this. I'm going to draw a line to cut that in half. Okay. And I'm going to show each of these numbers on the place value chart. Now I know that we already have an understanding of addition. Okay. We are just going to be working with a little bit larger numbers than what you did before. Okay. You still need to be careful how you line them up. Doesn't matter how big the number is. You still have got to be careful about that. So if we put 3,134, we would have 3 in the thousands place, 1 in the hundreds, 3 in the tens. And you'll do this with me in a minute. Not yet. Okay, there's our first number on the chart. See that? Okay. And then now our second number will be on the bottom. I'm going to just change its color. So 2 in the thousands place. What's in the hundreds place?
4.
4. What about the tens place?
9.
Ooh. Would another dot fit in there?
No.
Because I'm fixing to have a whole bunch of tens. Okay. So, and then a 3. I'm going to use this space underneath to help us too. Okay. So now just count up how many you have in each spot. 1, 2, 3, 4, 5, 6, 7 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 in the tens place. That seems strange. Okay. 1, 2, 3, 4, 5 hundreds. And then we've got 1, 2, 3, 4, 5 thousands. And so our answer would then be 5, 5, 1, 2, and 7. Is that right?
Totally.
Totally what?
Totally right.
Wrong.
This is my I don't think so
That's wrong.
face. It just happened. You said that, it just What's wrong here? Help me out, because this is not correct. Not correct.
Oh, I got it.
Okay, I'm gonna let you fix that totally right statement. So go ahead.
You're not supposed to put 12 there. You're supposed to carry the 1 and put it on 5.
Okay. Can 12 fit in one place value spot? No, it's like trying to park that bus in a space the size of a motorcycle. For a motorcycle. It's not going to fit there. And so Martin is right. That 1 is going to get carried over here. So when I have a bundle of 10, I can bundle it up. Let's see, this is 9 down here. I'm just going to grab one more. That's 10, isn't it?
Yes.
Okay. That 10 is going to move next door.
Nice.
See, what the place value chart is doing is it's helping you see what is going on when you're adding numbers. It's kind of like backstage in a play. Lots of things are moving and people are changing costumes and they're carrying things around and they're getting ready for. This is kind of like behind the scenes of what the numbers are doing. Okay. That group of 10 is going to move over. So I'm going to add a dot there. This is no longer here. So let me change that at the bottom. No 12s belong. If the 12 is there, it's only going to be there for like a second. And then we're going to move some over, So now I don't have, I think I'm going to need to erase that too, We no longer have 12 tens. We have how many tens, Brandon?
2 tens.
Just 2, because we took that group of 10 away. So there's 2 there. Now there's 6 here. Okay? So our answer is 5,000 627. Okay. Are we going to have to do every problem we do today on the place value chart?
No.
No. I know you know how to add. I know you just showed me with the application problem, you know how to add. But I wanted you, and I want you to know what's happening when we regroup, when we have to carry that number over. It's like a bundle of 10 is hopping over to the next place value, okay? Let's look at another one, and we're going to do this one together. So I want you to do two things. Don't write anything yet. Let me show you what I want your board to look like. Your board, and if you want to maybe draw a line in a minute, okay? On one side, you're going to have the problem. And I'm going to make sure I line up my numbers. All the place values are lined up. Even the comma is lined up because you'll see that is very important as well. 473. Okay, so on one side of your board, you're going to have the actual problem. And on the other side, we're going to draw a quick place value chart. Okay? So, and by quick, I mean quick. We're not going to take a long time to do this. Let's see, ones, tens, hundreds, thousands, and 10,000. That is probably big enough. And because we have labeled it so often, we're just going to abbreviate today the ones, the tens, the hundreds, the thousands, and the 10,000s. Okay, now we're going to need both of these things because on this one problem, we're going to do both of these at the same time so we can see what's happening as we go. So I'm going to give you just a second. You probably want to divide your board. You don't need quite as much room for the problem as you do the place value chart. Okay, but please quickly get these two things on there. Okay, remember, this is not art drawing, this is big math drawing. Double check that you have copied down the problem correctly. I saw earlier this morning, was it this morning or yesterday? I think it was this morning. It looked like somebody had copied down the wrong numbers on their board, and that, that throws off your answer. So just be careful. Double check these are correct. Label the top of your chart super fast with our abbreviations. Okay, so we're going to go ahead and do these at the same time. So please stay with us. This is one time where I want you to work with me, not ahead of us. Okay. All right, so we're going to put both of these numbers on the place value chart. I'm going to draw a line right there, and the first number will go up here with our place value dots. Again, this is quick. This is not, oh, let me draw that. Oh, that circle's a little crooked. Oh man, I did it again. Please don't do that. Okay, it's a waste of ink also. All right, so in the 10th, we can start with our ones. We've got 2 ones, and you're doing this with me. We've got 6 tens, Keep going. How many hundreds?
7.
7. And how many thousands?
0.
0. Jump right over that place. And then your 4 10,000s. Here's our first number. Okay. Our next number, I don't want that color. Okay. 3 ones. How many tens?
6.
No,
7.
we're in the second number. 7 tens. How many hundreds?
4.
Ooh, I can see some change is going to happen in some of these places. Again, no thousands, but we have 3 in the 10,000s. Okay. We're going to put them all together. We've got 2. Now, please stay with me here because I'm going to be bouncing back and forth between this and this because I want you to watch it as we go. You're going to be doing the same thing. All right, please don't. We're going to need a little space down here to put our final answer. But how many ones will we have all together?
5.
5. And is 5, that's a good number. It can stay there. It's not too big. When I am adding in my problem over here, my 2 plus my 3 is 5. Okay? So we've done that in both places. Make sure you've done that too. We've added the dots. We've added over here. Okay? All right. So like I said, you're seeing behind the scenes here of this problem. In our next place, whoa, how many dots? Valerie, how many is this going to be all together?
13.
13. Now, I'm going to write that at first. I think we all know that that's going to change. Okay? Am I going to come over here and I'm going to write 13 right there?
No.
No, y'all know that. Y'all have learned that skill already. So, how many, stay with me here, how many can I bundle up and move to the next place? It's that magic number. Yes. 10. So, I'm going to go in and I'm going to circle 10 of these. All of those and 4 more down here. And I'm going to draw an arrow to show that I'm moving those. Okay? I know that some of your dots and place values are very tiny. Just do this the best that you can. But you know what I can't forget to do? Is draw the dot over here. So I'm going to put that one right there. To add that, this right here just became one little dot. And I think I just accidentally, stop. Okay. Let's get rid of So you know what? When this stops behaving, I'm just doing that so I know that that is nothing but a big blobby mistake. Okay, my hand just hit the board right there. Okay. All of that in that weird shaped circle became one dot in the next place over. All right, so is this 13 anymore? No, what is it now?
3.
1, 2, 3 is all that's left. So, now we're working, right? There's a 3 there. Okay, so here we go. Back over to this place. 6 plus 7 is 13. We put the ones place, and we carry the bundle of 10 to the next place value. Boom. That's what just happened. That was a bundle of dots that just went over to the next place. That is why we carry like that. Okay. So now how many are in the hundreds place? Charlotte?
In the hundreds place.
All together. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So can 12 stay there?
No.
No, we're going to do the same thing. We're going to bundle up 10 of these. We're going to draw an arrow next door. See how we're doing that? Because we're showing what's happening behind the scenes. This is now going to have 1 dot in it because that bundle of 10 got to move over. Okay. How many do we have left here? Just 2. So I'm going to get rid of that. Okie doke. How many ones do we have, Miranda? Sorry, how many thousands do we have?
1.
Just 1. Okay, let's pause for a second and come back over here. When we added the 1, the 7, and the 4, what did we get there? Here? What is 1 and 7 and 4? Added together? 12. We put the 2 and we carried the 1. That is this 1 right here that just moved over. 1 plus 0 is 1. Okay, just like we have the 1 right here. And then how many dots? Everybody, how many dots altogether is in the 10,000s place?
7.
Okay, so 4 and 3 make 7. My numbers are the same, aren't they? 71,235. 71,235. Okay. That place value chart, all it's doing is giving you a picture of what's happening when we do this addition. Okay. All right, so let's go back to our chart. Okay. Now, we are not going to use the place value chart every single time we do one of these. In fact, I do want you to erase your whole board right now. Now, before we actually work this, and yes, we are fixing to just write the problem on our board and work it, but please don't do that just yet. Because down here they mention a tape diagram. Okay. How many of you have ever heard of a tape diagram before? Okay. How many of you have never heard of a tape diagram ever in your whole life? Okay. That helps me out just a little bit. All a tape diagram is a simple way of drawing a picture to show, to help you solve a problem. That's all it is. And a tape diagram is usually in the shape of a rectangle. Okay. Now, if this was my tape diagram, what I'm saying here is that there's both of these pieces are going to make a whole all together, right? This piece plus this piece is going to equal my answer. So they're not equal. One is a little bit larger than the other. So this piece and this piece are going to equal together my answer. We just don't have that yet. We don't have the whole number. Sometimes we're given the whole number and one of the pieces, and we're asked to find the other piece. What would the operation be that we would do to solve that? Yeah, subtraction, because we would take the whole and we would just subtract one piece, and it would give us the other piece, wouldn't it? So tape diagrams can be very helpful sometimes. But I just wanted you to see what it could look like for this problem. Now, one of the things that messes us up is not copying a problem like that down correctly. So as you write it on your board, go ahead and do that. Double check that you've written the numbers correctly and you line them up. I want you to go ahead and work that problem, and then we'll solve it together in just a second. We'll go over it, in just a second. Okay, go ahead. We're not doing place value charts or anything. We're just writing this and solving it. Okay? Alright, we're gonna start adding this. If you're not completely finished, keep going. Okay, make sure you are finding your answer. So y'all know we start on this end where the ones are, because as these get bigger, or if we have to carry, we need to carry them to a bigger place. So 6 plus 4, Gage, what's 6 plus 4? 10. So I'm going to put my 0 and carry my 1. I've carried that bundle of 10 over to the next place value. Caleb, what's 1 plus 2 plus 4?
1 plus 2 plus 4. 1 plus 2 plus 4 would be 7.
Okay, so 7 goes in the 10th place. I don't have to carry anything that time. 4 plus 7, Bailey? 11. A little too big to fit there, so I put the 1 from the 1's place and carry what's in the 10's place over. Okay, and now my comma goes there with the other commas. 1 and 7 and 8 is the same as 8 and 8. Okay, which is what?
16.
16. Put the 6 from the 1's place and carry that group of 10. Okay, Miranda, what is 1 and 0 and 2?
3.
3. That's not too big. I get to keep it just like that. Martin, what? Finish us off. 2 plus 1.
2 plus 1,
3. So 336,170. Anybody get that? Raise your hand if you got that.
Me.
Good. And all that is just careful addition where we've carefully added and carried over if we needed to. Okay. Let's do that. Let's give this a try. All right, clear your board. We are almost to our problem set. This is our last one we will do before our problem set. Okay, we're not going to do that anymore. Okay, thank you. All right, who can read that for us? Reagan, go ahead.
The Lane family took a road trip.
Okay, hold on. Faith, let's turn around and make sure we're hearing the details. All right, go ahead.
The Lane family took a road trip during the first week. They drove 907 miles. The second week, they drove the same amount as the first week, plus an addition to 297 miles. How many miles did they drive during the second week?
Okay. How many miles did they drive just in the second week?
You're the same. The second week they drove the same amount as the first week.
You got to make sure you don't miss something. Okay. All right. How do we know what to add together? Because what a lot of people want to do is just grab any number they see. Oh, it's addition today. Miss Wendy said we're doing addition. You know, it's on the target. Just grab any number that's in the problem and add it together. Be careful. Bailey, what do you think we're going to add together?
Because the second week, they drove the same amount, so you add the same amount.
So you add that number plus how much?
The first week you add it again to itself.
So you mean like 907 plus 907? Okay, but hold on. Trying to get that to move, but I don't think it will without that. Hold on. There we go. $907 the first week. 907 the second week, because it says they drove the same amount as the first week, plus an additional 297 miles. But they don't want to know how much the first week. They only want to know how much was the second week. So how many miles did they start off driving the second week?
900.
907, because it says they drove the same. But how many more miles did they drive?
907.
200.
No, that's what he said, but how many extra miles did they drive that second week? 297. So They drove that and then this much more. Okay, 4th grade word problems will sometimes, if you're not really paying attention to the way it's said, can be a little tricky. All right, let's figure this out then. Okay. All you need is this right here. So if we do the adding, what is 7 plus 7, guys? 14. Put the 4 and carry the 1. 1 and 0 and 9, 10 all together. Put the 0 and carry that group of 10. 1 and 9 and 2 is 12. 1,204 miles. And wow, that's a little messy, but hey, we can read it. Okay. All right, so our problem set, let me just explain it right quick. You think you can figure out what to do there? I know you can, okay? It is several just basic addition problems to get that practice of carrying, regrouping. It will continue on like this. This is the rest of our problem set. What are you going to do if they write the numbers horizontally like that? Yeah. Out to the side, you can stack them up, just like you've been doing on your board. Okay? All right, you may go ahead and put away your board, clear it off, your marker, your eraser, and as you're doing that, grab your workbook. We will take our restroom break and then come back and get started on this practice.